Hi, I'm Adeeba Rashid, and I am a data science and business analytics intern at Sparks Foundation. So today I'm going to discuss Task-6, that is prediction using decision tree algorithm, and the dataset link is being provided here. Now the problem statement that was given to us is to create the decision tree classifier and visualize it graphically. And the purpose of this is we need to have a new dataset of this classifier and would be able to predict the right class accordingly. So I've just started by importing the important libraries, that is pandas, numpy, seaborn, matplotlib.pyplot, and then just filter out the warnings. And then just I'm reading the data set. For that, I have written pd.read underscore CSV, and this is what our data set is. It is in the form of a CSV file, that is a comma separated value. Then in order to fetch the top 5 rows and top 5 columns from our data set, I have used the function .head, which will fetch the top 5 rows and top 5 columns. Then in order to fetch the last 5 rows and last 5 columns, I have used iris.tail. So this is what it looks like. Now, in order to get the information, the type of variables that our dataset hold, I'm using the function .info. So it can be seen that ID is holding a type int, then sepal width, petal width contains the float type, and then species is of object type. Now I'm just going to describe my data set. Now for that I've used .describe function, which will eventually tell the mean, median, count of our data set, minimum, maximum, count, mean, standard deviation, and rest of the things. Now data visualization. So for that I'm using a strip plot to draw a better scatter plot of the data set. So this is what it looks like here. Since each species has equal number of data points, so our data, that is iris data set, is said to be a balanced data set. Now I'm just plotting a disk plot of sepal length, then sepal width, then petal length, and then petal width. This is what it looks like. Now we'll find a correlation. For that, I'm just plotting a heat map of this data set. So this is, it can be seen that petal width holds a correlation of 0.9, then petal length, sepal length. Similarly, all of these correlation has been shown in this heat map. Now I'm just gonna plot a joint plot between sepal length and sepal width, and I'm just shown this with the green color. On x-axis there is sepal length, and on y-axis there is a sepal width. Similarly, I'll be using this joint plot to visualize the relationship between these two variables. And here it can be seen that on x-axis there is sepal length and on y-axis there is petal length. And I've just used purple color to describe this. Now again I'm using this joint plot, and on x-axis there is sepal length and on y-axis there is petal width now, and it can be seen from the brown color. Now, the observation that we come up across is that darker hexagon refer to higher concentration and brighter hexagon refers to lower concentration. Now, again, I'll be using this joint plot to show the relationship between the two variables on the x and y axis respectively, that is petal length and petal width, with the color pink. And then similarly for petal length and sepal width, I have shown it with the color blue. And then likewise for petal width and sepal width, I'll have shown it with the color red. Then I'm using a KD plot for plotting the data set against the univariate, that is a single variable. And then I'm using a rug plot to draw small bars along the x-axis for each point in the data set. And basically I've used JP. So JP is an acronym for joint plots here. Now next I'm just gonna plot a pair plot of all the species, and like I have dropped this ID column as well. So I'm just pair plotting this, and here you can be seen that this color is for Iris setosa, then here orange is for Iris versicolor, and this green is for Iris virginica. This is basically a pair plot of the observation. Now we come to the observation that clusters of species versicolor and virginica are closely related, whereas setosa is more distinct. From the result of pair plot, it is observed that all blue points are well separated with each other, like the two classes, but versicolor and virginica are partially overlapping with each other. Also in the pair plot, there are some feature combination which is very less overlapping between versicolor and virginica. So these features are vital for our classification purpose. Now I'm going to just do a feature engineering. So what is meant by feature engineering is basically it is the creation of new features from the existing features present in a data set. So by taking the difference from the features, like by taking the difference of sepal width from sepal length, we get the sepal difference, and by taking the difference of petal width from petal length, we get the petal difference. So this is what we have done, like feature engineering. So now we get the two different columns, that is sepal difference and petal difference. This is what feature engineering is. And then we are just like plotting this data set. So now it's again I'm plotting a pair plot of the iris species of the different columns, and it can be seen like this. Then it is observed that the information generated from this new feature is almost quite similar to our main features. Each combination separates this iris dosa, but has some overlapping between versicolor and virginica. So I'm just building a classification model, and for that I have just dropped this ID column. I told you that it is kind of a repetitive, so I just drop it. There's no use of this. So I'm just importing libraries. So from SQL I'm importing tree because we have to like apply a decision tree algorithm. Then from sklearn.tree I've imported decision tree classifier, and from sklearn.model selection I've imported train test split and cross validation score as well. So basically I am just separating the dependent and independent variable from the data set X and Y. Now I'm just splitting my data into training, testing, and validation set, and then splitting my validation test, like validation train and validation test among them. Then I'm just creating a decision tree classifier and training it with a training data set. Now, this is what it looks like, the output, and then we're just visualizing it. So I'm just plotting a tree, that is tree.plot tree, and then I'm just displaying it like that by 20 by 20. Now I'm just finding my due data set to predict the classes, and for that I'm just testing a model on a random test case and then predicting the label using iris virginica. And then I'm just displaying the predicted trial. So this is what the output is, iris virginica, and the object is, the data type is object. So the visualization of decision tree is now our model has been trained perfectly. Now we just want to perform the validation of decision tree across the validation method and to get the accuracy score. So accuracy, it comes out to be 0.93, and then I'm just going to check validation test data on trained model to get the performance matrix, and for that I have just imported multi-level confusion matrix and accuracy score from sklearn matrix, and then I'm just gonna display the accuracy of validation data set. So it comes out to be 0.83, and then I'm just also displaying my multi-level confusion matrix. So this is what it looks like. And then I'm just gonna check my model performance on unseen data set as well. So for that, the accuracy is coming to be 96.66, and this is what a confusion matrix looks like. Now I'm just gonna target my species, that is a species dot unique values, and I'm just gonna print the target. So it comes out to be iris setosa, iris versicolor, and iris virginica. So from sklearn import tree, the figure is like we just want to display the figure as well. So I'm just writing plt.figure, and that's 15 by 15, and then I'm just plotting the tree with the columns and the targets. So here what it looks like, the whole tree. So here we come to an end of our task. Thank you.